good morning, everyone. Thanks for joining and sharing your morning with me today. I know 9:20 can be early, especially for engineers, so appreciate that. Today we're going to be talking about JUnit 5 tests and the unidirectional data flow. And this is using LiveData in the Coinverse app, so I'll talk about Coinverse in a bit. This is a sequel, actually, to the first talk I gave on the unidirectional data flow using LiveData about 6 or 7 months ago. And I got the idea, I was actually listening to the Fragmented podcast that I'm sure a lot of you have heard about UDF, and they use it with RxJava, and I was super interested to see if I could create a version of this using LiveData. So that's kind of what inspired the first talk. And then after building the UDF flow out, I kept hearing about this is supposed to be great for testing, and working on startup teams in the past, testing had never really been something we allocated time for. So the last few months I've just been ramping up and learning as much as I can on the testing front and with JUnit 5. So a bit about myself before we dive into the details. I worked on the ad partnerships team at Google, helping app startups grow their business size. And then I worked on the engineering side at eBay for a small local e-commerce team. And then for the last year and a half, I've been building out Coinverse, which is an app we'll talk about, and also contributing to the Dash open source project for decentralized payments and cryptocurrency. So quickly, a bit about Coinverse. It's the first cryptocurrency app for audio news on the go. And I'd love for everyone here to check it out on the Google Play Store. And all of the code is also open sourced as well. So I really like listening to podcasts, and part of my inspiration for this was listening to podcasts on the go, plus converting everything from hundreds of thousands of RSS feeds around the world. So that was pretty interesting to me, and I've been working on it for the last year and a half. So taking a look at the UDF flow, a little bit about the history. So it was popularized by Facebook for React Native, and it manages different app states. So we'll talk about the view state, events, as well as effects. So a lot of the big companies here, it's going to walk around a bit. Yeah, so a lot of the companies here have put out great talks using RxJava. So today I want to look at using LiveData for this pattern. And some of the strengths of UDF, there's a linear flow of logic. It's easy to control the UI as well as asynchronous events. And as we see today, when you package things in a view state, view events, and effects, the tests are almost predefined, which is great. And then I've also noticed as well for debugging, since it's very easy to reason about the logic, it's usually quicker to debug rather than with like MVM and data binding, for instance. So before we get into the details, let's take a high-level overview of the game plan for today. So first, we're going to talk a bit about modularizing using UDF. So this means controlling the state flow with our view model, and repository. And then once our view model has been modularized, we can then test that directly with JUnit 5. So there's lots of different tests out there, and since I was new to testing, local unit testing seems like a great place to start, because you already have your view model and your events and state that are independent, so then you can easily test that with JUnit 5, whereas with Espresso, it involves a lot of the lifecycle events, and as well as with like integrated or instrumented tests, there's a lot more integration there. So once we have local unit tests, we can then expand either to instrumented tests or back to UI tests. So it's kind of a great entry point and great place to start for testing. So going into a little bit about what the view state, events, and effects actually mean. So the view state is all of the view's final persisted data. So we'll be looking at testing the content list in the main feed flow. View events, this can either happen from a user initiated event, or it can happen from a Android lifecycle event. So here, a user is clicking on a news article, and then that fires the view event. View effects, so these are one-time occurrences. This could be like a navigation event that happens, or this could also be like a dialog menu. So here, after user has organized and swiped different articles, then the business logic is telling the UI to update with a content swiped effect, and that navigates our items away. So the general structure for this, our view is creating the events, and then our view model is going to request data from the repository that handles network data as well as database information. And then the view model is going to either create the state and effects, or it'll update the existing ones that it has, and then the view can observe the state and effects changes. So let's talk about why I'm using the UDF flow with LiveData and Kotlin. So with LiveData, I really like that it's already lifecycle aware by default. So that makes it really easy. So for instance, if you're launching these events in your activity or fragment, if those happen to go away, then you don't have to worry about information leaking or having it be updated in the wrong place. With LiveData, there's a pattern that Jose Alcereca has talked about, and the link is provided here. So once this is published online, I'd definitely check that out. But essentially, it uses an event observer. So for like view effects, this is really useful because they're one-time events. So you want to make sure that they're not emitted more than once if like a user swipes an article. And then you can also use this for multiple events, of course. So like for WebSockets in Firebase, this is great because when information is updated in the LiveData view state, it automatically flows down to our main feed. With Kotlin, some of the basics, so there's data classes. I think everyone who's worked with Kotlin knows that. Seal classes are really nice for using this pattern. It's almost like an enum, but for methods. So I'll show you in a slide or two how this is used in a utility function to pass in a parent type, and then based on the child type, we can process that data in the specific way. So here's the extension. Well, extensions is another reason why I like Kotlin for this pattern. There's lots of built-in extensions, as well as it's really easy to create your own custom ones. So here I created my own send extension function for view effects, and it passes in our seal class of an effect type, and then based on the effect that's being sent back to the view, we can process that accordingly. And then also for Kotlin, it has coroutines, which is really nice. And I'll talk about flow in a bit, but this is great for interacting with the repository down to the business logic, or in my case, the view model. So the great thing here is that you can transform data, and you don't have to observe it all the way down in the UI. So great, we have the main feed loading. Let's see a quick implementation of how we'll implement the different state effects and events. So the first thing we need to do is define our models. And the view state and effects are going to look pretty similar. So they're data classes, and then all of the attributes are going to be live data that can be observed. So the view events, I originally actually created this as a stream of live data that was then passed to the view model. And I attended the Android Developer Summit in October, and I got great feedback actually from Yeats Boyar on the interaction here. And one of his pieces of feedback was to create a hard contract between the view and the view model, because before I was just passing a stream of events. So if the view model did not process one of the events, then it could easily be forgotten. So I actually refactored this to use the interface pattern, and that way there's a hard contract with the events happening and what the view model needs to implement. So what this looks like is in our view, in this case it's a fragment, we will create our interface and have a helper method in order to bind this to our view. And then we can see here as an example in our onCreate method, this is where the feed load event is actually called and passed, it's being passed through this interface to the view model, which is implementing that. So in our view model, as we saw before, the view state and effects, they had attributes that were live data. So the view state and effects themselves are also live data. So we have the view state that's changing data based on the live data, and then also its attributes can be updated as well. So it's important to note here, though, that these are immutable, and that way the view cannot change the state, which is important for the UDF flow and making sure it's a one-directional flow of information. But we do have our mutable state and effect changes here, so that way we can make changes in the view model where that's supposed to be done. And then we have our helper method here, which binds the event listener. So then in the view model, we'll implement the feed load method. And we can update our state and effects to populate that data down to the view. So the interaction between the view model and repository, I talked about this a bit in my last talk, and I invite everyone here to check out the link in the slides or the YouTube video. But essentially, the relationship between the view model and the repository, I'm using the loading content error pattern, and this is a sealed class. And originally, this is where I was using live data to return information from the repository to the view model. And this got pretty ugly because I was using switch maps in the view model to return that information and then do some transformations. So after the Android Developer Summit and seeing some good talks on flow and coroutines, I refactored the live data from the repository. So now all the network and database requests, they return flows, which is great because then we can transform that information in the repository and clean that information up and return just what's required in the view as well as the view model. So definitely would look into using flow, and my next talk I'll probably be talking more about flow as well, so stay tuned for more information there. Lastly, we can finally observe our information. So like I said, we have two live data objects. One, the state itself, which we'll observe, and then we have the attribute, which is the content list we're observing here. So I could probably break this out a bit. Right now it's nested. So I think in the future I'll probably refactor this a bit to remove that nesting. Great, so our feed content is loaded. But now we want to continue building awesome features and make sure we have tests so that way we don't break anything and have to check everything manually. So getting to our local unit tests. Here's a tool set that I decided to use. JUnit 5, which is the latest library from the JUnit team. MockK, which is great for creating our fake test data. And then AssertJ for actually testing the view states and effects. So JUnit 5, some of the reasons I like this a lot, it provides dependency injection built into the library. So this is going to use extensions instead of rules, which was used in JUnit 4. And then I think some of the lifecycle methods, I think the new naming scheme is a bit more intuitive. And then in the documentation, the JUnit team says that the core library should be updated quicker because of the newer architecture patterns they're implementing on their side. So MockK was an easy choice. Coinverse is written 100% in Kotlin, and MockK works with Kotlin very well out of the box. So we'll look at how it supports coroutine with the syntax here. And then we'll be looking at mocking the repository, the top-level functions, as well as some of the static Java methods that pop up for us. And there's a lot of good assertion libraries. So for MockK, that one I'm pretty passionate about, but I think there's a lot of options for assertions. I went with AssertJ. It's very easy to test your data classes with. And the purpose we'll be using with AssertJ is for testing our state and effects to make sure that we return the data as expected. So our overall strategy is we're going to take our view model and we're going to pass events to that. And then we're going to return the test information with MockK for the repository. And then we'll test the view state and effects with AssertJ. So if any of you have kind of followed dependency injection at all, I'm sure you've seen the quite lively debates on Twitter and Reddit. And the reason that I was thinking about the different dependency injection methods is because I know I need to keep everything modular. So there's a lot of, I guess like heated debates back and forth on these two. And I decided to kind of keep things very simple. And it's also important to note this past October at the Developer Summit, Google said they'll support Dagger 2 more, especially for Kotlin. But like I said, I want to keep things very simple. So I'm using singletons right now. The Coinverse app is fairly small, around 10 megabytes. And singletons are enough for now to keep things separated out. So what this strategy looks like for modularizing is any objects that will be used for the global scope, I can create that in the application class and implement that method. So in this example, we have a database that we're initializing when the app begins. And then in our singleton repository, that's where we'll actually use the database to return some sort of information. And then in the view model, we'll make a request directly to the repository singleton. So before doing this, the view model is actually creating the repository. So that created a dependency that we did not want in our view model. So cleaning this up makes our view model independent. And that way, when we fire requests to the database, we can pick that up with MockK, and we don't have to create the repository in our test environment. So before we dive into the details of the test, let's take a look at the overall steps. So we have our configuration, and there's a kind of a lot of edge cases here that we'll walk through, and everything is linked, so you don't have to worry about all the details. You can go back and check out that once this is posted. So first we need to configure our coroutine test dispatchers. The way this works in the Android environment is going to be different than in our local JUnit test because we don't have that Android environment there. And we want to run on the test dispatcher pools that I've created. And then for LiveData, a similar situation here. This is going to run synchronously in our JUnit tests, so that way it can run outside the Android environment. And then we'll talk a bit about JUnit 5 and injecting components. It's one of the features I like a lot for reusability, especially for me. I wanted to test the entire content view model, so it turned out to be about 61 tests. So anywhere we can reuse components, that's going to be huge. I'm using parameterized tests here to make sure we test different scenarios and use cases. And the main feed here, the architecture is reused for the labeled content screen, the dismissed content screen. So there's a lot of different cases that we can test with parameterized tests to check things out. And then the second step is actually mocking the data we want to return. So steps 1 and 2 is probably about 80% of the work. And the great thing is once we've kind of gone through all those edge cases and set up the configuration, it's very easy to create our events in JUnit 5, make the assertions in AssertJ, and then we can verify again in MockK. So for the configuration details, we'll use the extend with annotation. This is specific to JUnit 5, and it lets us create this test extension. So in the test extension, we can implement lifecycle methods and then also note the parameter resolver. And this is what we'll use for injecting our components. And then the two attributes here, the test dispatcher and the view model, these are the two components we'll be injecting into our test. So in the test extension, before every test runs, before each, it makes a lot of sense, the naming there, so that's nice. We will set our coroutine dispatcher, and then we'll also set the LiveData executor here. This just makes sure that we're using test dispatchers and LiveData is run synchronously. After every test, we want to make sure we clean this up. So we'll clear the dispatcher as well as set the LiveData executor to null. So the second thing that I was talking about was the injection component. And here we're implementing the parameter resolver methods. So the important thing to note is that for supports parameter, what we're doing here is checking the type of component that's being asked for. And then in the resolve parameter, we're going to then return the necessary type. So here we're just looking at the view model, but we also need to add in the test dispatcher. So we would just check for multiple types and return the corresponding one. And then another great feature of JUnit 5 is the get store functionality. So instead of every time, let's say the view model is requested, instead of returning a new view model each time, we can check to see if one has already been created. And if not, we'll create one. But if there's already one there, we can reuse that for our tests. So it's a nice performance improvement there. Great, so we know our main feed is looking good, but what about the error cases? What about edge cases? So this is one reason why I like parameterized tests a lot. And with parameterized tests, we can pass in a stream, and we define the data class of attributes that we want to test. So for here, I have a test case data class, and then I'm testing different screens as well as different loading states. So I'll pass in a loading state, a content state, and an error state. And I can make sure all of the according view states are returned as expected by the view model, as well as any effects that should also show up. Also important to note here, we can see the test dispatcher at the bottom. That's being injected, and we're wrapping our test in this run blocking test for coroutines to run on the test dispatcher. So we finally have configured everything. Now we can mock some data. So we're going to mock our main feed requests. So this is what the repository looks like, and it's returning a flow of eventually a page list. So that's what we need to return as well with MockK. So since we're going to be using the repository throughout all of our tests, we can also include this in our test extension and reuse the functionality here. So for MockK, we'll use the mock object syntax, and this creates our repository. And then we want to also make sure that after all of our tests have run, we unmock and return everything to the original transformation. And this makes sure that we're not accidentally saving any states to be used in later tests. So if we look at our feed load test here, we'll actually define what type of data is returned before we do anything else. So before we create any events, before we assert any values or verify. So mocking a page list is not actually very straightforward. I'm hoping that in later libraries, this will be included as a utility or extension function. But I had to do some digging on GitHub, and I provided a solution that you guys can check out in the Stack Overflow link here. But essentially what we're doing is in MockK, we're defining co-every. So this is because we're using a coroutine. If this was using LiveData, for instance, or RxJava, it would just be simply every without the prefix there. The thing that's important is that get main feed has to match the exact method call coming from our repository. So that way when it's called in our test, MockK can step in and provide our mock data here. So in our utility function here, we're just going to return our page list using the utility function. And there's a few other useful mocks I kept running into that took some figuring out. So two of them is running into static methods. And since Coinverse is 100% in Kotlin, it wasn't from my code, but from various libraries that were called as a result of the repository. The second use case was top-level constants. So these don't have function values that you can mock like a normal function. So we need to handle those accordingly as well. So for static functions, instead of doing mock object like we did before with the repository, we'll do mock static, and then we're simply providing the name of the library. And then we don't really actually care about the information that's being called in this Android library, Firebase remote config. So we'll just set relaxed equals to true, and that sets the object empty. For constant values, this is interesting because the way it works is it takes the constants.kt class, and the way Java actually processes it is it turns it into constants.kt. So we need to provide the exact package path that it's compiled in Java. So for here, we mock that static package, and then we can return our mock error network requests. So this is great for constant value. So we finally set up our mocks. We'll get our page list returned back. Now we can actually create our events after that mocking step. So what we're doing here is the feed load is the event we defined earlier. So we're just going to create that event, and then we're passing that into our view model, and that starts and initiates the flow for the feed loading. So any state changes and effects, we'll want to test to make sure that works as expected. So we're going to be looking at the content list here. That's the attribute in our view state. And we're going to be making assertions on that after we fired the event. So one does not simply observe live data in a JUnit 5 test, unfortunately. Jose Alcereca has provided a great pattern. It's a util function for this. I think this will probably also be published directly into the libraries for this rather than being in the sample app. But for now, this is something that you need to go in there and use. So how this works, if you remember, we have live data as the view state. So we first observe a change in the view state, and then secondly, we observe a change in the attribute, which is our content list or our page list. And we can assert that the actual meets the expected value here. And then for the view effect, it's the same exact concept. So we're observing the live data change that happens after the page list is loaded. So for here, that's updating the ads, and we just want to make sure that that fires as expected. So the great thing is that when it does not work as expected, JUnit 5 and parameterized tests are very clear on what's not working. So in this case, we're expecting it to be empty for whatever reason, and the actual has value. And it shows us in the highlighted part there what the actual test case is where this fails. And then we can see in the code comments here, or the output, we can see the expected versus actual. So this is very useful. A lot of times when you're writing tests quickly, you might have small errors that throw things off. Finally, we're at the verification step. So this is important to make sure that everything that you expect to be called is called, and there's not additional code that is being called out of the expectations. So what we'll do here, similar to the co-every, we'll use co-verify, and we want to essentially say we want to make sure get main feed list is called. And then in our confirm verified, we want to make sure that all of the methods in our repository are verified. So there's two different cases that I ran into a lot. The first one is when a method is called in the test, but we forget to verify it. So this is a useful check, so it reminds us, hey, there's something being called that we're not really expecting. So this reminds you to verify that at the end. The second issue was when a method is not called in the test, but it's included in the verification. So this is a good indicator that something is probably not working right. The test might be even passing, but it could be because there's a method that's not being called. So important key indicator here. So using this pattern with UDF plus testing the view model, I was able to get 96% code coverage for lines of code in the view model, which makes up a significant amount of the app functionality from listening to content, organizing it, as well as looking at the different feeds. This is the core architecture, so it was great to get that amount of coverage with local unit tests. So to recap on the strategy that I used, I created the view model in JUnit 5, fired those events, and then used MockK to return the test data, and then we used a search A to then make sure the state and effects were observed correctly and as expected. So some of the next steps, like I said, this is just for local JUnit testing. So now I can either expand and test the repository and start testing the database as well as the network, or I could go and test the UI. So this is a great starting point, and the eventual goal is to have full instrumented testing, and that way it would test everything from the UI to the repository and network layer. So yeah, the main takeaways is when you modularize your app and separate the view model logic from your repository and your view, you're then able to test the core business logic, which I think is a great way to get started with testing. So thanks again for spending your morning with me. If you want to follow up on future updates on this topic, feel free to follow me on Twitter. You can send me a direct message on LinkedIn. And then I'd love for everyone here to check out the Coinverse app on the Google Play Store. And all the tests I wrote are open sourced on the GitHub profile here. So I would love code feedback. I've been working with testing for the last couple months, so I'm sure there's some very experienced folks here that can provide guidance there. And yeah, just wanted to thank everyone who's provided notes and kind of the foundation for putting this structure together, as well as some direct feedback. So it's been fun to build this so far. Thanks so much.